Doors are closed. We may as well get going. All right. So my name is Doug Tomei. I'm a staff engineer on the Tableau Prep product. I always have to think about that because I keep wanting to say Maestro. That was the name of it before, and then before that it was Loom, and now there's like Tableau Concert, which is the version that's running on the server. So there's a lot of names, but they all mean the same thing, more or less, in terms of the mechanisms. So we are, I guess it's about midpoint for TC. Is everybody enjoying themselves? Yes. Yeah? Cool. Like to hear that, right? If everybody's like really run down and not feeling good, then that doesn't seem very encouraging. But all right. So I've been at Tableau for about 3.5 years. And before that, I was 6 years at Amazon, and before that, a couple of startups and a consulting, worked with a consulting company, worked for a defense contractor. And over the years, one thing that I have observed over and over again is that it's actually relatively easy to gather large amounts of data. And it's actually relatively straightforward to make visualizations or metrics for things which are sort of bottom line effects, right? They're the direct observables. But it's a lot harder. It's a lot harder to figure out why things happen. Sort of what is the underlying root cause, and that is kind of a passion of mine. And it's actually in no small part a reason why I wanted to come and work for a company like Tableau, because getting down to those things requires significant data analysis and really just an attitude that you have to be willing to explore things which are not entirely obvious when you begin. So when I sat down to write this talk, I had, a couple months before, read a book by Colin Woodard called American Nations, right? And the basic idea is that some of the complicated history, in politics and cultural misunderstandings that we have are due to the fact that the United States isn't really a homogeneous culture, right? In fact, he picks out, based on historical reasons, 11 American nations, all of which have different cultures. And so I'm going to use that kind of as a driver for this. It's more of an example. I don't think we'll come to any profound conclusions by the end of the talk, but it serves as a useful example of an actual real-world data prep problem, which in my experience has a very familiar feel for a large swath of data prep kind of issues. And then we'll kind of talk about how the data prep mechanisms work in that context. So start with culture. Culture seems like a nice squishy topic for data analysis. So what is it? So culture is basically just the set of norms and behaviors, the expected, when somebody behaves in a certain way, you expect them to behave in a certain way, and that's established by your culture. More importantly, it's also gives you a lens, when you've been raised in a cultural lens, to decide what's good, what's bad, what's dangerous, what's not, right? Is smaller government always better, or is government necessary to deliver sources and serve as a counterweight to large corporate influence, right? Are threats primarily from outside of the United States, requiring a large, strong military, or is the threat coming from social instability because some people are left behind? Who knows, right? But it's some of the answers to those questions constitute that lens. So this is Woodard's book. Actually, he's written a couple of them. The sort of basic idea comes from a laser pointer you can barely see. Comes from this doctrine of first effective settlement. The idea is that a new culture, a new regional culture is born when a group of people move into an empty area or into an area that they effectively make empty by killing off or driving out the previous inhabitants. But even though that initial settlement may only be a few dozen or a few hundred people and ultimately grow to be millions or tens of millions, those cultures are stable over time. And that's primarily because of two mechanisms. One is sortation. So when new people come in to join your culture and they have options, they are more likely to join a culture that feels familiar to them. So maybe speaks the same language, has similar values. And so when they move in, they tend to reinforce the values of that culture. And the other is assimilation, which is a multi-generational process. So the original inhabitants might come into a foreign culture, and they might never even learn to speak the language or adopt the customs, but their children will. And by the time you get down to the third or fourth generation, it's possible the only things left of the original culture are family names and some holiday traditions and some ethnic foods. So this is Woodard's original map. And so I should say that all of these cultures, or except for 3, actually extend beyond the bounds of the United States. So cultural boundaries are no respecter of political boundaries. But he's given them names which are sort of semi-arbitrary, and some of them influenced by history. So like up here, we've got Yankeedom, right? So this is the Pilgrims, Plymouth Rock, Bunker Hill, Valley Forge, right? All of the history that, at least when I was a kid, we learned in high school. But actually, a lot of our history ignores some really significant things that happened in the other cultural areas, likely because the dominant culture of the time was Yankeedom and the thing they call Tidewater here, which is the importation of English aristocracy, right? The place where George Washington and Thomas Madison came from. But there's a number of other cultures. Woodard definitely brings a viewpoint to this. He views a lot of American culture as essentially a conflict between Yankeedom up here, which is sort of very community-oriented, and the Deep South, which is much more hierarchical. But that's a question for another time. You may have noticed, unless you came from a nearby place, that when you came to New Orleans down here, there's a section here called New France, which is a distinct culture, and so you crossed a cultural boundary. And actually, if you kind of walk around and look at things, you might be able to feel a little bit of that. All right, Woodard's theory basically comes from history and his own reasoning and so on. And from my point of view, from a data analysis point of view, I want to know what the data says about it. So an intriguing tidbit of data came out last year. So Woodard's book was published in 2011, and in a completely unrelated work, last year, there was a group of academics who analyzed 770,000 genomes from Ancestry.com and found that we have genetic clusters which actually are remarkably reminiscent of Woodard's cultures, at least east of the Mississippi. So genetic clusters happen when, over a long enough period of time, people intermarry within certain groups, right? In order for them not to just have their genomes diffuse out, there has to be some kind of barriers. They can be physical barriers, but in this case, there aren't any significant physical barriers. But there can be cultural barriers. People tend to marry people that come from their similar backgrounds and so on. And so this is not proof, but it's kind of intriguing. All right, so that's the problem I set out to analyze. And so there's some problems. I mean, how do we actually measure culture? It wasn't obvious to me how we'd even do that to begin with. I'm going to start by basically reproducing Woodard's map. And that's at the core of all the flows that we have, because oddly enough, US Census data and so on doesn't really respect any of Woodard's cultures. So we have to map from the data that we have into the data that we have into this American nation's view of the world. So we're going to start by looking at batch flows. So flows in Tableau Prep are basically the fundamental mechanism we have for saying, what do you do with the data? How do you clean it? How do you reshape it? We run flows in 2 primary modes. One is batch flows, and batch flows are when you've already got a flow created. We're just going to run the flow on all of the data, wherever it happens to be. The other is interactive mode, which is the mode that you're usually in if you have Tableau Prep on and you're dragging nodes around and you're clicking on nodes and seeing the profile pane and things like that. So there's a bunch of stuff that actually interactive mode is much more complicated than batch mode, which is why we're going to start with batch mode. But there's a number of caches and things like that. So we're going to talk about some of the basic mechanisms that we have with batch mode, which is the simpler mode, and then we'll move on and look a little bit at interactive mode. So I'm going to start with this data set. So this is sort of the basic map from county and state data onto the Woodard's American Nations label. And so we can start our flow. With this. So the beginning of this flow is basically I put this in a Postgres database, so we're going to create an input node, and we're just going to enter the data for the server. This is basically exactly the same experience that you have with Tableau when you connect to a database. For the purpose of this example, I'm going to claim that I need to filter off Hawaii data. I don't really need to filter off Hawaii data, but I want a simple but not completely trivial query to do that. So I'll bring Hawaii back later. But for now, our goal is to look at the data and then filter off Hawaii. And so you notice on the left, we have this thing we call the recipe pane, which we'll talk about soon. And then I'm simply going to say I want to filter off the data, filter off the values that are Hawaii. And then I'm going to save this output to a hyper extract. And then if I want to, particularly for complex, or in this case, very visual data, we can augment the capabilities for looking at the data that are inherent to Tableau Prep with the Tableau analysis product. And all you have to do is right-click and launch it. In this case, we're going to say that nation is just a string, basically. It has no geographic role, because nation in this context doesn't mean what Tableau thinks it means. And then the rest is pretty just standard Tableau map stuff. So we'll drag it down, we'll get the county and state map, and then we'll generate the colors for Woodard's nations. And lo and behold, we have Woodard's map without Hawaii, right? No big surprise. OK. What did you just see? Well, there's several answers. So one answer is you saw the operation of a particular software system. And that software system is designed as a client-server web application. So we're kind of tricky. We actually make it look like it's an installed monolithic application, but it's not really. If you're at all familiar with, if you've gone to websites, you basically see some kind of UI rendered in your browser, and there's a particular species of UI called a single-page application, which makes it look, as opposed to like the sort of older style of pages where you click around links and go to next page and things like that, a single-page app feels a little richer, like an integrated application. But it's a style of writing code for TypeScript. So if this was a website that you went to, this is the part. This TypeScript is the part that would run in the browser on your desktop. This section here that's labeled HTTPS is the part where you'd go over the internet to talk to servers out in the cloud somewhere. This is the part that would run on those servers. And then in the case of Tableau, because we're a data analysis product, we will also use, for the things that we use to generate queries, we will also use the standard Tableau platform, which is the same thing which is used by the analysis product, to spew out queries in a database-independent form. They go into a query pipeline, which optimizes and transforms the queries and does federation and some other things, and then has this dialogue with the connector platform to generate the database-specific SQL for whatever database type you happen to be talking to. In this case, this Postgres server is the one that we connected to. So it's not a database server which is used by Tableau Prep. And in fact, if you're familiar at all with web applications, the main thing missing from this diagram that you'd find in most web applications is a database server which is used by the application. Tableau Prep the Tableau Prep desktop has no such database. And that's primarily the reason why if you were to go in, for example, and go to this Postgres database and type in the credentials and then shut Tableau Prep down and come back and open up the flow again, you would find that you'd have to type your credentials in again because there is no permanent memory other than the flow files and so on. We don't store sensitive credentials or sensitive information in those files, and there is no other database server to store them, right? That's the realm of things like Tableau Server. So as I mentioned, you're actually interacting with a browser, and that browser is Chrome. But there's this package up front called Electron, which basically wraps Chrome and fools you into thinking that it's an installed application. So this is a very deliberate strategy, which was set out in the beginning by Will Pugh, who's a principal engineer He was the first engineer on the Tableau Prep project. He's actually working on the Maestro desk today. So the primary reason for it is that way back in 2015 when the project was started, we knew that the place where we were going was not to build a desktop product. That's just a waypoint. The place where we're going is that plus Tableau Online and Tableau on-prem servers and so on, and therefore if we want to not start over again when we get to the server product, we have to build things in a way that they can be used for the server product. And so what you've essentially got is a web application that is intended to be used by one person, one flow at a time on one machine. And so we wind up just adding things to it to go to the more general case. But we don't have to actually throw this away and do something else. The back end for Tableau, well, I should say this. A very typical way to build backends is to divide the functionality into a set of services. And there's a program called Spring, which you may or may not have heard of, but it's basically a manager for groups of services. So a Java service is basically just sort of a coherent piece of functionality that handles one kind of thing. And so the kinds of things that we have in the back of Tableau Prep are there's a bunch of stuff that has to do with caching and connections and files and so on. The only two that we're really going to talk about at all is this flow executor service, which is the thing that actually compiles the flow and turns it into queries, and the flow operation service, which manages binning. Although you'll see implicitly the function def service, you'll see there's a couple of places where we put in Tableau functions. They're actually pulled from the C++ stack. It's not a reproduction of the functionality. It's exactly the same thing. And so if somebody goes and adds a new function to the Tableau expression language, we'll just automatically pick it up. Desktop integration service, you saw a little bit of operation. You saw a little bit of that in action when I launched Tableau to analyze the data. And there's a bunch of other stuff which is actually pretty interesting, but can't possibly have time for it. And then we have the status service, which is the thing that actually keeps track of, we issue a flow, it takes some time for data to come back. You need to service these things asynchronously for performance. It's the thing that takes care of that infrastructure. We won't be talking about that at all. All right. So, question, what is a flow? Well, it's another question with lots of answers. So one answer is, it's the little picture that you see up on the flow pane at the top, right? It gives you the sense of how you're going to transform your data, what order the steps happen. Another answer is it's a specification defined in loom-lang. So loom-lang, also defined by Will Pugh, is a language that captures flow definitions. Its only current textual form is in JSON, but we could have other front ends if we wanted to. And the third is that it's a specification, and if you combine that specification with a selection, you generate a query. It's the definition of a query, right? And that makes sense. So if I were to go to this little simple specification and click on this node, the input node, I get a certain set of data back. If I go and click on this node, that node has a filter that the first node does not, and therefore it has a slightly different query. It has the query where Hawaii is filtered off. And this trick that we do with the specifications is something that is a core functionality that we use over and over again in different contexts. And in some ways, it's kind of the central pattern of Tableau Prep. You probably haven't had a chance to work with Tableau Concert yet, which is Tableau Prep running on Tableau server. But you'll notice when you do that when you run a job, you actually don't pick a flow. You pick a particular output per flow. Right? And that's exactly the reason is this output, this specification plus the selection of this output, which is really selecting the node before it, is a particular query. And that query is likely to be different than some other output that's in the flow. And so, it's sort of pick a node from the specification, generate a query from it, is the basic pattern that we're going to explore here. The other thing, which is not obvious at first sight, so you notice here we have this input node. We have this node that was added when I said add a step to it. So what it actually did was we grayed the input node out. When I said add a step, we added this thing called a container node. So a container node contains a subgraph, right? So the top level thing is a graph. The container node contains a subgraph. And you can see the subgraph being built up when you build up the recipe pane. So when we look at Loomlang here, you'll see a reference to a container node, and then inside of that, this filter for Hawaii. And of course, we can have more than one step inside of a container node. It can be sort of arbitrarily complex. All right, so this is Loomlang, defined in JSON. It has two major components. One is the nodes in the graph, and the other is the connections that are used. And so every connection has a type, and this one is a SQL connection, because it's connecting to a SQL database. It has this isPackaged thing, which is basically just a flag to the system. So you can take, if you have like local Excel files, CSV files, and so on, you can package them up in a TFL file. And then if you run it, Tableau Prep is smart enough to basically pick the files out of the zip file and use those as the inputs. And this is definitely the way you should go if you want to share a flow that has local data. It's much easier than trying to ship the CSV files or something around. And it's analogous to tflx files. And then, of course, we have connection attributes, which is just sort of what you'd expect. The name of the server, the name of the database, and this class, which tells you the type of the connector, in this case, Postgres. So if we look at the nodes, the input node also has a type. In this case, it's a load SQL node, and it has a name, which is a name for people to see. And then it has this ID. And the ID is a GUID, a globally unique identifier, although globally in this case means unique within the flow, right? If you had multiple flows, like in a server context, you could potentially have the same GUID. That would not be an issue. This is an input node. And then we have this thing called next nodes. So the next nodes is essentially the pointer to the node that follows. So this is the input node. The empty container node, or it's not empty anymore, the container node that I added also has assigned a GUID, and so the next node is the GUID of that container node. There's also this thing called the namespace. So in Tableau Prep, it is perfectly reasonable, and it happens all the time, that you have table names that come from different places, which have to be named unique, but their names are exactly the same, or the column names are exactly the same. And Tableau Prep needs to keep track of which is which. So the answer to how we do that is with namespaces. So if you're familiar with scopes in programming languages, this is essentially the same idea. So if you have a single input-output node like the container node or the filter that we have now, the namespace is basically always going to be default. If you have a more complicated situation, for example, if you have a join, then the namespace on one side of the input of the join is named left, and on the other one is named right. If you have a multi-node union, then we assign GUIDs for the input namespaces, just so we can keep everything straight. Now, don't confuse namespaces with the other mechanism. So when we do a join, and you'll see this here also later on, and we have duplicate fields, which frequently happens in a join, we'll take things like if you had two IDs, one from one table and one from the other table that was joined, one of them will still be named ID, and the other will be ID-1 or something. Those names are generated for the benefit of the user. The Tableau Prep doesn't really need them. It doesn't really use them. So you can always feel free to go and rename them or get rid of them if you don't need them, because Prep will, under the covers, has its own naming scheme based on namespaces, and it will do the right thing. So in this case, if we expand out the next node, then this is where you see this container node. And so the container node has a next node ID, which in this case points to the output node, and then inside of the Loom container function, then it has nodes, which you'll notice looks exactly like this thing at the top for nodes, and it's a subgraph. In this case, it happens to be this filter node. It's a range filter, and then it has some fields which are specific to the filter type. All right, so all of nodes have a type which has a version component and a type name. And the version is actually interesting. It's more flexible than the traditional versioning for Tableau Prep, and I wish I could talk about it because it's actually an interesting topic, but I can't. And it has the GUID, which is unique within the flow, and it has a base type, which is one of input, output, transform, container, and supernode. Transform is actually probably most of the nodes in the flow. They just basically take, like a filter, transforms the data from one form to another. In this case, transforms it from a form where Hawaii is part of the data to a form where Hawaii is not. And then every input and output node exists in a namespace, and I basically talked about all these rules already. Okay, so those are kind of the basic rules. So what do we do with them? The answer is we take this Loomlang and we compile it. Basically, it gets compiled down into queries. And so the compiler, so we have the flow executor service, which provides the API. And then we have the Loom engine, which is in charge of a two-pass compiler. The first pass of the compiler iterates over the nodes. It figures out the type interface, figures out the type information for columns and so on, figures out how they're all connected, and then we go through a backend compiler which creates logical and physical models. So like physical models are models that describe an actual instantiated table, right? Or there's a calculated model that describes the effects of a calculation, things like that. And then we basically take those, we put them in order, which is what an execution plan is, and from that, we transform it into AQL. So I'll say AQL if you're like really, really picky. This is actually a logical query. If you don't understand what the difference is, don't worry, it's not important. So we transform it into AQL, which is a database-independent form of query, which is exactly the same as used by the rest of Tableau. And that query, logical query, goes in the query pipeline. It gets optimized. There's a conversation that happens between the query pipeline and the connector platform. And then eventually we produce a database-specific kind of query for that. So this data platform is shared with the rest of Tableau. So this is not something unique to Data Prep. As improvements are made to the data platform, Tableau Prep just sort of automatically inherits them, improvements in performance and so on. So we tried really hard when we built Tableau Prep not to build a system where we're forced to reinvent the wheel. We want to build on top of all the work that Tableau has done and not start something completely new. So if we look at, so this is an example of a logical query for this particular flow. This is not really meant to be read by humans. And so I won't subject you to more than one of these, but I wanted to give you a little flavor for it. It takes some practice to read these things. So you can pick out little components of it, though. So here, you have to kind of read these from the inside out. So here you can see where we have an equals operation, an equal between state and the constant hi. And then we're going to AND that, or do a logical AND, with a not is null for Hawaii, and the reason for that is that the equality comparison rules for various databases are a little wonky for nulls. It's not always what you expect, and then we're going to take the inverse of that. Through a conversation with the back end, that in this case gets transformed into a Postgres query, which is SQL, which is intended to be read by humans, and so is definitely much smaller and easier to comprehend, but it's the same logic. Right? We're just picking out the columns, and then we have our logical condition, which filters off Hawaii and compensates for the behavior of null. We use hyper a lot, and sometimes in places where it isn't always obvious. So one of them is if you have a local file, like you have a CSV file, we'll take that file, we'll ingest it into hyper, and then we'll issue hyper queries from that. A lot of the reason for that is performance. Hyper is very, very carefully tuned to use the resources on the machine efficiently, to be memory efficient, and so on. It's a really good execution engine, and we exploit that in a lot of different places. Hyper is also used for federation. So federation is the case where I've got a table in my Postgres database over here and the different table I want to join it with in my Oracle database over there. Neither one of those two databases can join those two tables. So the way that works is the federation engine will take the query that we issue, it'll break it into pieces, send a piece to Postgres, send a piece to Oracle, stream the data back into Hyper, and then finish the join in Hyper. That also is exactly the same functionality that is used by the rest of Tableau. It's actually part of the data platform. It's not part of Tableau Prep per se. So this is an example of what would happen. So I'm showing you these things because later on I'm going to show you some tools that will let you go and actually look at some of the queries yourselves and understand. And I've actually got a little homework exercise for people who happen to have Tableau Prep to understand a particular type of query. But you'll see that in the end, the query that we issue for Hyper is pretty much exactly the same as the one that we issued for Postgres, right? To Tableau Prep, there's nothing really special about Hyper, except for the fact that in some cases we have to cooperate in setting up data in the database, whereas with Postgres, we just assume that somebody else already took care of that. And so you'll see a few setup things. So there's creation of the table, and then in this case, there's a copy that is used to fill the table before we actually issue the query. All right. So that is the basic mechanism for running batch flows, right? We capture a specification, we select a node, we go through this infrastructure to generate a query, and then basically the rest is the data platform. We push the query out, we fetch the results back. Other things like federation and stuff can happen under the covers, but really a lot of that is invisible to Tableau Prep per se. All right, so culture seems like an odd topic for data analysis, but it turns out that people have spent time thinking about this. And sort of the granddaddy of the field is this guy named Hofstede, and he started looking at this stuff at IBM in the late 60s, and actually his initial work was dealing with company cultures as opposed to national cultures, and later expanded. So after decades and decades of work and doing, issuing questionnaires and isolating it down, he basically, him and his group, isolated cultural comparisons down to 6 more or less orthogonal dimensions. Woodard, the guy who wrote the Nations book, actually wrote a different book, which basically looks at this dimension, the individualism versus collectivism in the United States. But I'm actually, honestly, I started at the top of the list, so that's the reason why I'm going to do power distance. But power distance is one of the dimensions. It's the degree of acceptance of unequal power. At least that's the definition that Hofstede gives it. If you actually look at the dimensions that they come up with for measuring that, it's more like sort of just whether power is unequal or not. Right? The most extreme example is a dictatorship. Right? If you have a dictator who can do whatever he damn well pleases, that's just different from a country like the United States where there's a separation of powers and checks and balances. And so in that respect, the United States is a low power distance country, and other countries have higher power distance. And again, more or less because it started at the top of the list, I'm actually going to concentrate here on doing some analysis on income inequality. So one lesson, though, or a couple of lessons, is first that there is no one number that really defines cultures or how you compare cultures. It's actually sort of a cluster of values. And you see this sometimes in optimization, particularly where there is no one strong measure that basically is the answer, but instead you use a cluster of weaker measures, and together they can actually give you insight that no one measure can give you, and that's the case here. The other thing is that these measures are all comparative. So there's no, you can't say that the culture is 6.0 on the Hofstede scale or something like that. It's, you can say that one culture has greater power distance or another, but that's the kind of language. So there actually is a fairly ready-made measure for measuring income inequality called the Gini coefficient. And essentially all that it is a comparison of people's incomes. So if we were to calculate the Gini coefficient for this room, basically for each pair of people in the room, we'd look at the difference in their incomes, add them all up, and then divide by a factor that basically normalizes the value to be within a range of 0 and really close to 1. It actually asymptotically approaches 1, but never actually gets there. So if everybody in the room had exactly equal incomes, the Gini coefficient for the room would be 0. If there was one person that had all the income and everybody else had nothing, it would be a number that was close to 1. It's actually 1 over the number of people in the room. All right, so at this point, we want to start looking at census data. Well, census data is not in the form that you'd want. It's actually even a little bit coarser than you might hope at first glance. And so let's just go through and look at a flow that can take Gini data that I downloaded from the American Consumer Survey, which is part of the Census Bureau, and see what we have to do with it. So it turns out that the Gini data is available in a bunch of CSV files, 1 year's worth of data for each CSV file. And so in this case, I'm going to read it in as a wildcard union. So a wildcard union basically is something where you point to a particular directory, and when you run the flow, it goes and reads all the files in that directory. You could do a different kind of union where there was one node for each thing. I chose a wildcard union in this case, both because there's a lot of files and because if I add more files later on, I can just dump them in a directory and not have to change the flow. And then I created a somewhat augmented version of the filter we looked at in the first part. Mostly it has the spell out name of the state because that's the form that the census data has in it. And so then we're going to do some cleanup. There's a couple of census-specific IDs that do me no good, so I'm just going to get rid of them. And you'll notice on the left, we're building up this recipe pane. So when I added that new step, I added an empty container node. Now we're building up the graph inside of it. And if you look in the 50-page document that the Census Bureau puts out, you can find that this oddly named HD02 and so on field, one of them is the Gini coefficient, one of them is an error coefficient, which is there because the data is actually not derived from the exact income for each individual, but rather from income ranges. And then over here, you'll see when it gets revealed again, when you do a join, there's a column which always tells you the name of the file that went into the join. And in this case, the metadata about what year it is actually buried in the name of the file. It's not in the data itself. And so I created a little calculation to actually pick off the year with a regular expression, add 20 in front of it, and then we'll flag it as a date. And then we finally get our way down to the location information. So it's all glommed together in one field. It's like Ada County, comma, well, I forget what state it's in. Alabama, probably. Idaho, okay. So we split it apart, and we're going to give them more friendly names, a county and a state name. And then we're going to join them together with our map data, and we'll be finished. Maybe. All right. There's a couple of problems. Your first clue is that these values, well, I actually have to finish the join. So county names are not unique within states, and so you need to join by both county and state. All right, so we got some problems. Your first clue is that these values are all in red, right? That's the Tableau Prep join node way of telling you that something is not matched. So we specified an inner join, which basically you can tell is because just the intersection of the circles is highlighted. In addition to the actual results of the query, this tells you a lot of information about what's matched and what's not unmatched. So on the left here, in the included column, this tells you what is matched in the blue section. So the blue is where our join data came from. This is our actual census data. The orange is our map from state and counties to the nation's flag. I would expect that all this data would be matched, right? There is no data from a county which is not in the United States, and therefore I expect it all to be matched, but it's not. I mean, and sort of, if you examine it, you can tell immediately that there's one problem, is that this is like Adams County, right? Whereas Adams is just the name of the county here. So we're gonna have to do something about that, but it's possible that there are other problems as well. The interactive operations in Tableau Prep are designed to help you find those kinds of problems, right? So there's like very explicit flags, like in the join node, but there's also more subtle things that you should use as well. I mean, if you get to really complicated visualizations, the Tableau desktop, launch Tableau desktop and look at it, that's the way to go. But for data prep, in a lot of cases, you're really looking at low-level, row level problems. And so we'll look at a couple of things here. So our most basic thing is the operation that you don't even have to interact in, which is binning. So binning is the thing which generates those histograms, those vertical, those horizontal or vertical bar charts, horizontal bar charts. So there's a number of binning strategies. So we're actually going to do the same trick we did with Tableau flows, where you've essentially selected a node, and then we're going to use the engine to generate the query in a certain form. But the binners, on top of that, they add in, which are in the flow operation service that I mentioned earlier, The binners actually apply different strategies on top of that. So if I've got a range of real data, I want to have certain bins which are somewhat different than if I have a range of integer data, which is somewhat different if I just have a column which is a whole bunch of unique values. Sort of the binning strategy is the thing that applies different approaches depending on the situation. So if we just look at, again, what happens when we do binning, binning will happen when we just add a step and look at the data. So these are the horizontal histograms that we're talking about. And again, you can see, when we have a case where there is real data, or integer data rather, there's a certain set of binners which are a little different from the case where we have a range of real data. So if we were to look at the queries that are actually generated from this, come on. One more slide. It's this. So things are starting to get a little more complicated because the data is a little more complicated, but it's essentially the same thing, except that we've got some additional characteristics that apply to the interactive environment that don't apply to batch flows. So we have the parameters which are shown in the profile pane. You notice that one of these is labeled as dimension. So we're basically going to issue one of these queries for every column that's displayed, in the profile pane, and then we're going to use count one. So hyper, I should make this comment. Whenever it's not obvious to you what database you're dealing with because you dragged in a node, the answer is the database you're dealing with is hyper, right? And so you're going to see a bunch of hyper queries. Hyper is basically the Postgres dialect, so if you're familiar with that, that will tell you how to read these things. So this count one is basically the same as count star in a lot of other databases. So we're basically just counting up a particular measure, a particular dimension, and the size of the bar is basically the value of that count after the binning strategies are applied. It'll go through and issue a series of queries, and basically, if you look to the logs, you'll see this as dimension kind of dance from field to field. There's a limit of basically 1 million. It's actually 1,024 times 1,024, and that's enforcing the sampling limit for interactive mode. So we limit the amount of data that we will fetch for interactive mode in order to keep the interactive response quick. We also use caching and hyper under the covers. There's things that you can play with in the input nodes to influence the sampling. So this million limit, and it's just taking the first million rows as the default mode. You can choose random sampling, and you can fiddle with these values as well. Random sampling takes more time, so it's not something you really want to do or you want to play with it carefully, because with a large data set, random sampling can actually take quite a long time. And then we have this from extract. This extract is a cached hyper table under the covers. And so when you click on a node, we'll pull the data in, and if you don't change anything about it, if you went back to it later and clicked on it, you're actually fetching the data from a cached hyper table and not going out to the primary database again. And again, that's just to keep your interactive performance snappy. There's a section down here, which is basically has to do with the indexes. Although it looks like you can scroll through the data in each column if there's a lot of data, in reality, we're only fetching back a little piece of it at a time. And so you may see, if you scroll through something and look at the queries that come out, you'll see this query issued multiple times, and these values will change as you page through the various data. And that's all that's going on. And then at the end, we group it together, it gets counted up, and then we sort nulls to the top. So the other main operation is, with that basis, the other main operation is brushing. So brushing is just binning with a condition. And so in this case, we have some null values in the data set for the Gini coefficient. Don't expect any null values. I want to know why. So this is pretty easy. So I've got null values. Click on the null. Now we'll see the things that go with that null value. And if you look at the primary spreadsheet, you'll see that it actually has 2 header lines, which we're not smart enough to deal with. And so we wind up with a counting named geography. But we know there's no real counting named geography. And so we can just filter it off in this case. That's like the shortest memo ever. So this is actually just a variation in the theme. So this is basically binning with a condition. This is what we call brushing. And so it's all pretty much exactly the same thing as you know. There'll be a thing called dimension and so on. But the difference is that when you clicked on that null condition, we added a condition to the query, which in this case says that field is null. And so you only get back the data that goes with that null. That's really all that's happening. But this is actually really powerful. When you start to examine the data in those views and you poke around, you should be really curious. And when something doesn't look right, basically click on it. That's your strategy. And see what goes with it, and a lot of times that's all that's necessary. And once you kind of get used to it and go with the flow, it's actually surprising how quick the process can be to reshape your data. All right, and then when I went in and basically said exclude value, we added a node to, you saw a node added to the recipe pane. We basically added a node to the graph that was inside the container node, and of course, that means that we altered the specification and therefore altered the query. And so this is the query that went to Hyper to move this all back. We're pulling data from the cached Hyper table, but now there's another condition, which is basically says the label is not equal to geography. So when you look at it, if you kind of try and look through the software to see the operations that are happening, think this is the query generator, what query am I generating, and basically this will always give you the answer to what's going on. So now I just want to finish up the example here. So in this case, we've taken care of that null, and we've matched more fields. But we have this problem with the counties not exactly matching up. So to fix that, I'm going to go and rename the county to a different name. And then I'm going to create a calculated field that has some regular expressions in it, which you can go and look at if you're really interested in the download. But basically, we're just trimming off the counties and municipality labels and things like that to get an actual county. You'll notice that original county was propagated down from the previous node when I renamed it. So prep is intelligent enough to keep the labels consistent. But in this case, I actually wanted it to be county, so I'll just change it back. And I've mostly got my data matched. But down here, we have this weird accent over Dona Ana County in New Mexico. So I choose just to replace it. And now, actually, all the data from the blue is matched. So this is all my census data. But I still have some data which is not matched from the map, which I certainly did not expect. And so if I click on it, then I can kind of see what data is matched. And there's a bunch of it, but it's not really obvious necessarily what's going on. So in this case, I'm going to choose to go back to Tableau, the analysis product, to visualize the map data and see if I can see anything. And so this is exactly the same thing we did before, just use the standard mapping capabilities in Tableau. And you can see that I made a bad assumption in the beginning. I assumed that if I downloaded data from the Census Bureau, partly because I had downloaded other data from the Census Bureau that had covered all the counties, I'd assumed this data would actually cover all the counties in the United States, but it doesn't. And so I actually wound up, once I realized that, going and calculating my own Gini coefficients from the basic data. The other thing, too, I just wanted to mention in passing, so I'm a big proponent of sort of cleaning up your data model. So when we created this join, we created fields that were duplicates, right? So we joined on state and we joined on county. So there's a state name that comes from one side of the join and a state that comes from the other, a county that comes from one side and a county comes from the other. If you are actually going to, particularly if you're going to give this to somebody else and they wind up with two counties, they're going to wonder why they're there and what makes them different. And the answer is that doesn't make them different. So just get rid of the duplicates and make nice names for them. It only takes a couple of seconds and it's actually a very good practice. Next slide. There we go. So in the end, and this is not my revamped data, this is the data you actually saw, we can look at it and see what it says about the different nations. Now, again, this is like 6 dimensions in the cultural comparison, and each dimension has several measures. This is one measure from one dimension. Be really careful about interpreting anything. However, This particular data is actually pretty consistent with Woodard's observations. So the part of America, the nations that he flags as the most community-oriented, the most egalitarian, do in fact show up as having the lowest power distance in terms of the Gini coefficient. The one that he tends to harp on the most, which is the Deep South, is actually in the top half, but it's also not the top either. So, you know, like I said, it's one measure. It needs a bit more work. All right, so I wanted to leave you with some tools to look at things yourself, should you feel so inclined. So your main source of information is going to be the log files. And so you look for the My Tableau Prep repository. There's a little different locations on Windows and Macs, but it's all documented online. The two main log files, there's a bunch of log files that will appear in there. The two main log files that you really care about are hyperd.log, which is the queries that go to hyper per se. And as I said, if it's not obvious to you what the database is, then it's hyper. And then there's log.txt, which is a more general log file. So if you are dealing with Postgres or some other database or something, then you can look in here. These log files are JSON. There's one JSON object per line. And it is certainly possible to just open it up with an ordinary text editor and parse through it. It takes a little bit more work, but I highly recommend downloading the Tableau log viewer. It's free. It's on GitHub. It's already compiled for you and everything. It's actually pretty easy to install. And so, using Tableau log viewer, I'm going to give you a little exercise. So that join node, which shows things that are in and out, doesn't really get powered by an inner join, which is what you as a user specified. It's more complicated than that, and it has to be, because it's showing you things which do not show up in the output of the join that you specified. And so the question is, how does that work? So I'm going to give you this hint. I'm going to play a little video where we use the Tableau log viewer. If you want to do this, then search for full. And the reason for that is that part of the answer to the question of how this works involves a full join, which means those join nodes are really expensive, but they're also very useful. So in order to get the logs generated in the first place, you have to go and do the operation. So in this case, it's opening up the flow, selecting the node. That's it. Now the query has been done under the covers, and we create it. Now if we go and fire up and read in the log from the hyperd.log, search for full, we'll find the query. And I deleted the rest of the logs here, so there won't be only one. You might have more than one. And then in here, if you look for sort of the core of this join, you'll see that it's this. I'll highlight it here in a second. You'll see that it's this full join, but there's a bunch of other stuff going on in terms of how the calculations work. And so, really, it's kind of look at those, look at the conditions, and remember that you're trying to find the things which are the product of the inner join, but also not the product of the inner join. And that's how we produce all the different data. OK, a word on TFL files. So TFL files are just zip files. So if you want to open them up and take a look at them, just use a standard zip utility and unzip them. If you're familiar with TWIB versus tflx files for the rest of Tableau, this is not that. So TWIB files are bare XML files. TWIBXs are also zip files, and they're only used when you package up data. We simplified things for Tableau Prep. They're always zip files. Honestly, the only reason we even have a tflx file as opposed to a TFL file is the support guys wanted an easy to identify naming scheme on emails, so that when we get emails from customers, they have special processes that they use to make sure that we're careful with customer data, and that makes it easy for them. Tableau Prep doesn't care. It's just always zip files. So inside of the zip files, there's this Maestro metadata stream. So the streams inside of zip files are analogous to directories and files on file systems. Maestro metadata is basically the manifest. It names the other streams. It also has some stuff in there that has to do with managing document versions. The one that you're interested here is mainly flow, and so that's the Loom-like flow that we looked on. Feel free to open it up. We will never store, like passwords or other secret information in there. You can't get yourself in trouble by doing that. All right, I just wanted to finish up by saying a couple of words about running Tableau Prep at larger scales. So Tableau Prep Desktop is architected as a client-server system, but it's simplified because we made limiting assumptions, right? We assumed one user at a time, you're running one flow at a time on one machine, right? And there's actually a lot of stuff behind the scenes. We lock stuff down. If you tried to go and contact the web server that was running in Tableau Desktop from off of that machine, you couldn't do it. There's certificates and stuff running behind the scenes. If you tried to just open it up in a browser, even though it's really a browser-delivered product, you couldn't do it. And that's all for basically for security purposes and limiting cross-site scripting attacks, and there's all kinds of stuff that bad people might want to do that we want to make it hard for them to do. So the porting per se of Tableau Prep functionality to Tableau Server is mostly adding on the stuff that relaxes those assumptions, right? So many users, many flows at the same time, many machines, although users aren't directly exposed to that part of it. And so we're using the same flow execution service, exactly the same, like exactly the same code in Tableau Concert. I always have to think about the name. It's only from last week, by the way. We're using exactly the same flow execution service. We're using exactly the same versioning service. We're just adding on pieces that deal with the multiples of whatever. And so there's a flow orchestrator service to set up connections. There's a flow publishing service that lets you publish flows. There's a central flow service which basically deals with administration. So I want to get a list of my flows, and I want them limited by site, and I want to be able to do searches and all that kind of stuff. So the practice, basically the work for bringing up Tableau Concert, Tableau Prep on server, is really just extending the models that we already have for server. For backgrounder support, for secure, we actually use the same mechanisms for secure credential storage, adding permissions for flows, and that kind of thing. The first version doesn't have web authoring in it, but that's sort of like the next thing. Again, it's sort of variation on the theme. We're going to use the same code for Tableau Prep in server. You just have to split it out and add in some add in some things like administrative views which don't exist in Tableau Prep. The other thing is that there are a number of efforts underway inside of Tableau that had to do with the data platform. Tableau Prep is a user of the data platform. It's not actually the implementer of it, but as those things come to fruition, because we're just reusing that as the code base, we'll just automatically be the beneficiaries of that. There are some things that are specific to Tableau Prep, particularly when dealing with larger data sets, or with the fact that unlike the Tableau analysis product, we actually have outputs. And so today, if you run a Tableau Prep flow, we'll pull data down from some other source. We'll do stuff, we'll generate hyper extracts. That's not necessarily the mode that you want to work with large data sets, though. So for example, if you had a large Oracle data warehouse or big tables in BigQuery or something like that, the last thing in the world that I want to do is pull down terabytes of data into Tableau Prep, and then particularly if I have the output table in BigQuery or whatever, ship it back out, right? That's going to be inherently slow. And so particularly in a data warehouse scenario where the data both starts in the data warehouse and ends up in the data warehouse, what we want to do is construct a query, ship it off to the warehouse, have everything run, and not have Tableau Prep handle the data at all. That's not something that we can do today, but that's the direction that we're going. Kind of sort of implicit in that, and just for general principles, is being able to handle incremental updates. So if you have a typical data warehouse, it might grow to terabytes, petabytes, some very large size, but it doesn't get there like all in one day. It's the product of oftentimes years or decades of daily or weekly jobs running and adding a little bit at a time. Tableau Prep actually can't handle that capability today, but that's another thing that we're going to wind up doing. Another interesting scenario for our users is that it's not uncommon when dealing with large data warehouses for the big data set to be out there, but needing to be augmented with some smaller data set, which is typically captured in a CSV or an XLS file. And so rather than pull down the big data to the place where the little data is and then joining them together or whatever, we want to take the little data and ship it off temporarily to the big database, have the work there. Basically, this is moving the computation to the data as opposed to data to the computation. And that's something that we're going to do in time to come. So just to finish up, tomorrow, when somebody asks you what you heard here today, I know I've thrown a lot of stuff at you, but there really are 4 main points that I wanted to emphasize. One of them is just that Tableau Preps are specifications that get turned into queries. And of course, we've looked at several queries. Tableau Prep Desktop is a client-server system, which has actually a lot of implications for the ease with which we can implement Tableau Prep functionality in concert, right, in the real server setting. Tableau Prep is built on top of the data platform, so we're not rebuilding. It's not like some separate ecosystem. It's not something different. As Tableau enhances the data platform, Tableau Prep will get the benefits of that. And finally, Tableau Prep is architected to scale, even though today many of the features aren't yet built out. So Tableau Prep is actually a very young product. Other ETL products in the marketplace are much more mature. But from the very beginning, there was a vision for where we're going. And so we are incrementally executing on that. It's the last talk, so that slide is useless. There is a couple of talks. So the preparing your data the Tableau Prep way is more of a general introductory talk to the use of Tableau. I highly recommend it. The how to aggregate friends and influence pivots is a more specialized talk on aggregates and pivots, but also if you're trying to learn how to use Tableau Prep, I think that's a good talk. Also, please take a few minutes and complete the session survey. And thank you for your attention, and I'm happy to take any questions.